Welcome to a slow, beginner-friendly lesson on update, delete and the where clause, made for absolute beginners. Editing begins. In earlier lessons you created tables and inserted rows. Today you learn to change rows that already exist, and to remove rows you no longer need. The two commands are update and delete. Both are powerful, both are dangerous, and both depend on one tiny word, where. Get where wrong and you change every row in the table. Get where right and you touch only the rows you meant to. By the end you will update a user's email, delete inactive users, and understand why transactions let you undo a mistake before it sticks. Two commands, one safety word. Here is where you stand. You can create a table. You can insert rows. But data is not frozen. People change their email address. Users go inactive. Orders get cancelled. You need two more commands, update, to change existing rows, and delete, to remove them. Both are simple to write. Both are easy to get wrong. Today you learn them carefully, with safety built in from the start. From inserting to editing. Until now your tables only grew. New rows in, nothing changed, nothing removed. Today you learn to edit and to delete. Until now it only grew. Quick recap. You import SQLite 3, open a connection to a database file, and grab a cursor. The cursor is how you send SQL and read results back. Select id, name, email from users returns two rows, Ada and Grace. Today we change those rows. Same cursor, same connection. Only the SQL is different. Same cursor, new SQL. Update is the command that changes values inside rows that already exist. You write update, the table name, the word set, and then the column equals its new value. Then a where clause picks which rows to change. If you forget where, you change every single row in the table. That is the whole fear of update in one sentence. We will say it many times today. Change what already exists. Look at what happens with no where clause. Update users set active to 0. Every row in the table gets active set to 0. Ada is now inactive. Grace is now inactive. Everybody is inactive. One command, every row, no exceptions. You almost never want this. Always pair update with a where clause that targets specific rows. Everybody becomes inactive. Where is a filter? Read it as, only the rows where this condition is true. Where it equals 3 means only the row whose it is 3. Where active equals 1 means only the rows currently marked active. Where turns a scary every row command into a precise, surgical one. Always read where aloud before you run the query. Ask, which rows will this match? Read it out loud. Here is the safe update with a where clause. Update users set email to a new value where it equals 1. Only Ada's row changes. Grace is untouched. We use question marks for the values, the same parameter trick you learned for insert. It keeps you safe from injection and it keeps the SQL readable. After update, always call con.commit to make the change permanent. One row, not all rows. You can update more than one column at once. Separate the column equals value pairs with commas. Set email to a new value, active to 1, where it equals 2. Grace gets a new email and becomes active again in a single command. This is faster and cleaner than running two separate updates. List the columns, then list the values, in the same order. List the columns, list the values. Walk through the whole flow in your head. You write update or delete. You add a where clause that picks specific rows. You read the where aloud and ask, which rows will match. Then you call execute to send the SQL. Then you commit to make it permanent. If anything looks wrong, you can roll back instead of committing, and the change disappears. The safety net is real, but only if you remember to use it. Think before you commit. Update and delete without a filter is a flood. With the right word, the same commands become precise surgery. Surgery, not flood. Delete removes rows from a table. The shape is the same as update. Delete from, the table name, then where picks which rows to remove. Forget where and you delete every row in the table. There is no recycle bin. The rows are gone. So treat delete with even more respect than update. Always where. Always commit after, only when you are sure. Removed rows do not come back. Here is the safe delete. Delete from users where it equals 5. Only the row with id 5 is removed. Every other row is untouched. We pass the id as a parameter using a question mark, just like with insert and update. After delete, call con.commit to make the removal permanent. Until you commit, you can still roll back. Parameterize the id, where accepts many comparison operators. Equals matches exact values. Greater than matches rows above a number. Less than matches rows below a number. Delete from users where active equals 0 removes every inactive user. Delete from users where age greater than 90 removes everyone over 90. Read each where carefully, the wrong sign means the wrong rows. Equals, greater, less, like is a special operator for matching text patterns. The percent sign means any characters here. Like capital A percent matches any name that starts with capital A, Ada, Alan, Anna. Like percent at spam.com matches any email ending at spam.com. Like is how you search inside strings, not just match them exactly. It turns where into a small search engine. Percent means anything. Say it one more time because it matters most. Forget where and you touch every row. Update without where rewrites every row in the table to the same value. Delete without where empties the table completely. Both are catastrophes. A good habit, write where first, before you write the rest of the command. Decide which rows, then decide what to do to them. Write where first. A transaction is a group of database changes treated as a single unit. You start it with begin. You make some changes. Then you either commit to make them permanent, or roll back to undo all of them as if they never happened. The key idea, all or nothing. If anything fails halfway, you roll back, and the database is exactly as it was before. That is what makes databases trustworthy. All or nothing. Here is a transaction in action. Begin. Then 2 updates that turn Ada and Grace inactive. Then roll back. Both updates vanish. Ada is still active. Grace is still active. Nothing changed. This is the safety net. You try a change, you check the result, and if it is wrong, you roll back. Only call commit when you are sure. Try, check, roll back. A practical example. You write a function called update email. It takes a connection, a user ID, and a new email address. Inside, you create a cursor, run update users set email to the new value where it equals the given id, and commit. Because the values are parameters, the function is safe no matter what email the caller passes. This is the shape of every update function you will ever write. A function you will reuse forever. Another practical function. Delete inactive users. Run delete from users where active equals 0. After execute, cursor.rowCount tells you how many rows were removed. Commit the change. Return the count so the caller knows. This is real, reusable code. 2 lines of SQL, wrapped in a function, safe and small. Row count tells you what happened. Hold these 4 ideas. Update changes existing rows. Delete removes existing rows. Where filters which rows the command touches, always included. And transactions let you undo a batch of changes with rollback before they become permanent. If you remember nothing else, remember where. It is the difference between surgery and catastrophe. 4 ideas, hold them tight. Next lesson goes deeper into safe queries with parameters. You saw question marks today, next we explain exactly why they are safe and what they protect against. After that, we move on to working with multiple tables at once, using joins. Then we close the section with hashing, the foundation of protecting user data. Phase of point 8 continues. Safe queries come next. Transactions give you a quiet safety net. Try the change, check the result, then commit or roll back. The net is real. Thanks for learning update, delete and where. Next we go deeper on safe queries with parameters. Be precise, be safe.